Welcome to the lesson 16 of the Advent of SysML v2. This is a training series consisting of short videos and exercises brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and today we are exploring value rollups and advanced calculations. Systems engineering isn't just about individual components. It's about understanding how those components work together. By the end of this lesson, you will know how to aggregate values across collections, how to build chain calculations with automatic dependency resolution, and how to create conditional logic that adapts to system state. In SysML v2, you can define calculations directly in your model. Syside Automator will evaluate them automatically, resolving all dependencies. This transforms your model from a static definition into an analytical engine. Change the configuration and the analysis updates automatically. Let me show you what I mean. Here is our Santa-Slay model with calculated attribute values. Notice we have defined three sets of example calculations. The first example shows collection-based calculations. We count reindeer, sum their power, and calculate the average power. The second example builds a three-level dependency chain for load analysis. This consists of total weight calculation, load per reindeer, and safety margin. The third example shows conditional logic. We determine flight mode based on weight and max speed based on the flight mode. Let's take a closer look at each example. The first example focuses on determining collection size and rolling up values. On line 56, reindeer count counts how many reindeer are in the team. Using size sequence function instead of hardcoding number 9 means calculation is always up to date. Avoiding magic numbers is a good engineering practice. On line 57, total power aggregates power values across all 9 reindeer using some numerical function. Each reindeer has different power values in different units. Dancer at 7 horsepower, Vixen at 4.8 kilowatts, and Rudolph at 4950 watts, and so on. Syside Automator automatically evaluates each reindeer's power, handles all unit conversions, and sums them up to get the total system power. You don't write loops or manually convert units. You define what you want calculated, and Automator figures out how to do it. Lastly, on line 58, average power calculation expression is specified using the results of the previous two calculations. Automator resolves these dependencies automatically. Reindeer count gives us 9, total power gives us 54,000 watts, average power gives us 6,000 watts. Now let's build complex metrics using chained calculations. This second example has a three-level dependency chain for reindeer load analysis. At level 1, total weight attribute combines the sleigh weight of 850 kilograms with the sum of all reindeer weights. Each reindeer has a different weight, so adding them together results in 1640 kilograms, and the total weight is 2490 kilograms. At level 2, load per reindeer depends on both total weight and reindeer count values. This tells us how much weight each reindeer pulls. This is currently equal to approximately 277 kilograms. At level 3, safety margin depends on load per reindeer and max safe load value, which is 375 kilograms, defined at the package level. The safety margin calculation result is 98.33 kilograms, showing how much additional load each reindeer could handle before reaching their safety limit. When we evaluated safety margin, Syside Automator resolved the entire dependency graph. It evaluated load per reindeer after calculating the total weight, which itself required summing up each reindeer and sleigh weights, as well as calculating the count of reindeer. The good news: you don't need to manage this dependency chain manually. Syside Automator does it for you automatically. The third example shows conditional logic where values change based on system state. Note, we are yet to learn SysML state machines, so we are modeling the flight mode as attribute for now. Flight mode value depends on total weight from our previous example. If total weight exceeds 2500 kg, the sleigh switches to heavy haul mode, otherwise it operates in agile mode. Since our total weight is 2490 kilograms, we are under the threshold, so Sleigh operates in agile mode. Max speed then depends on flight mode. In agile mode, max speed is 140.4 km per hour, while in heavy haul mode, it is reduced by half for safety. Since we are in agile mode, max speed is then 39 meters per second when converted to SI base units. Notice the unit syntax. SysML v2 supports two forms: string form like kilometers per hour speed unit, or calculated form where you compose units from base units. Here we divided length unit by duration unit to get speed unit. Let's run evaluation and see what we get. There are 9 reindeer with total power of 54 kilowatts. Average power is 6 kilowatts per reindeer. The total weight is 2,490 kilograms. Load per reindeer is approximately 277 kilograms. And safety margin is 98.33 kilograms. Thus, the flight mode is agile, in which the max speed is 39 meters per second. We accomplished a complete system level analysis from model-defined calculations. The script simply evaluates attributes without any loops, aggregation logic, or conditionals in our code. All the complexity lives in the model itself. Now, this is where it gets interesting. These calculations are always up to date. Right now we have just the reindeer and the sleigh. Let's add Santa to the model and update the total weight calculation. Here is Santa added as a reference item, just like in lesson 5. We set his weight to 120 kilograms and updated the total weight formula to include him. Let's run the evaluation script again and see the results. Total weight now exceeds the 2,500 kilogram threshold, so the system is in heavy haul mode. Consequently, max speed is reduced. The calculations worked as expected without having to update the Python analysis script. SysML model update was sufficient. The same pattern applies to real engineering scenarios such as calculating system total cooling requirement, tracking total weight, and always knowing the remaining budget, aggregating resource utilization data across subsystems to optimize the resource allocation. The model becomes an analytical engine that evolves with your designs. Lastly, your new challenge task is to practice these value rollups and chain calculations. Check the blog post for detailed instructions and code examples. Share your experiences and feel free to ask questions in our community forum. Links and information how to get access to Syside Cloud is in the video description. Like the video, subscribe to our YouTube channel, and click on the bell icon to get notified about future lessons. Take care and happy modeling!